Very good morning to everybody. Daniel from Technik. Thanks for having me here. Thanks to the organizers for bringing everybody together so that we can share our experiences. For me, myself, I'm going to talk a bit more on the pace of technology as well as the industry and what customer needs, because I think we are pushing on different fronts. Technology definitely will push as high as possible, but like what Michael says, you must put in practical solutions into our solutions as well, so that we can actually solve real world problems that is cost affordable to customers, right? So I'd like to give a brief on what Technik is about and our journey on robotics throughout the years since we have founded. Okay. We are founded like 17 years ago, 17 years in the run since 2006. So we are actually system integrators. We are not really specifically producing products and systems, but more on system integration. So we need to have a diverse experience in different disciplines so that we are able to deliver practical and realistic solutions to our customer, right? So it's founded by actually 4 Singaporeans. They call themselves race car engineers, right? So when we first started, they wanted to build race car parts, right, in Singapore and to sell them, but you know that that doesn't work out. So we are forced into the robotics sector, right, by somehow, right? And we are into robotics, automation, and also special vehicles. We are into a few domains, primarily in the defense, homeland security. We have commercial, industrial, healthcare, and lately food and beverage industry, which we find that there is severe manpower shortages, and we like to go into that sector, right? So we are made up of a few business units. I think the key ones will be Technik Square. This is a division that specializes in bespoke solutions for robotics and automation. And our iconic product is actually the bomb loader that serves the Air Force, the Singapore Air Force. And we are actually selling this product to overseas as well. And for the special vehicles, we have Trigen Automotive as the business unit heading this. The iconic product will be the Red Rhino that is used by SCDF. Someone else will call it the LFAV, right? Light Fire Attack Vehicle, right? And on the extreme right, you can see that we also develop food cooking systems. These are at infancy stage. We created a subsidiary called Chef Roboto for it. And we are embarking on a very exciting journey in the next few years. So for today's session, I'll focus a bit more on Technik Square, the special projects department that does a lot of crazy projects throughout the years. As you can see, as one shot, you can see that there are different solutions for different industries from a different TRL level, from low TRL to high TRL level. Okay, but we not go that low. We will start off at around 5 to 6, and then progress all the way to 9, which is a full-fledged product with all the iOS support as well. So we are into farming, vertical robotics farming, and you can see tunnel inspection robots that run through 40 km of the underground tunnel that is manned by the SP group, as well as a firefighting robot that enables you to force multiply by the Homeland Security, and developing projects like a mobile hospital delivery robot whereby we serve food trays to the patients. That is a bit more experimental because when we serve things to patients, it's not like cobot whereby the robot can actually hit softly, touch softly onto the patients. This arm is not supposed to even touch the patient at all because we are afraid that the patients will actually sue you if you touch them just by a bit, right? So it's a different kind of safety mechanism. And even in public spaces like click and collect robotic systems that we implement for the Funan Lifestyle Mall, I think that is very refreshing because in public spaces, we have our own set of challenges. So we did things from indoors to outdoors to ruggedized to defense domain. So we are a team of around 90 to 100 engineers in Technik. That's our strength. Okay, let's start off our journey. We mainly classify our robotics into 4 areas, 4 A's that we call it. It comes from assistive, whereby certain semi-automated robots will actually help and enable a person to do more, then follow on by automation, which everybody knows, then the autonomous part. Then after that, when we gather enough data, we will use analytics, the smartness of it, right, to make sense of the data, which we are actually doing right now. Okay, the first 5 years is interesting. Remember, we talked about selling car parts and don't work out, and then we forced to go into robotics, right? So back then, way back then, right, we are into flying robots, we call drones, right? Whether it lands on the ground, when it lands on the sea, we are doing that. Anything that flies back then, right, is a big thing, all right? So we are absolutely crazy about that. And then we are into small platforms, there's wheel platforms, track platforms, putting simple payloads and enable them to do simple tasks, right? So that's way back then, Arduino, Autopilot, all these are interesting stuff, but we move on from there. What happens after the first 5 years? We began to, okay, the very first 5 years, we talk about fun factor, right? Anything that's fun, we are crazy, we're a small group, we want to do that. Then after that, as we progress, we find that we need to earn some money, correct? So we get to know this Gartner curve, right? Not too sure if anybody knows that, but a new hype usually starts from the left-hand side, and then after that, everybody goes, wow. Then after that, through the technology and experimentation and through using it, people find that it falls short of expectations. Then people start to lose confidence. Then after that, it cools off for a while. Then engineers begin to wake up and do a bit more. And then after that, it moves to the right of curve and is kind of ready for the industry, right? But we have actually products along the entire curve, which we'll explain later. Right. So we begin to focus a bit more on the social and the P&L portion. P&L to survive, definitely, and also a social part. We want to do something that means a lot to the customer to actually help Singapore as well, because we take pride in our engineering. We want to make engineering great in Singapore, right? So that's actually the key mission for Hope Technik. So on the left-hand side, you can see AMRs. These are early days. Anything that moves from point A to point B is actually great, right? Deliver stuff in semiconductor industries, right? And also semi-assistive robots, right? That, for example, in the bed mover, we plug something into the manual bed, and then we are able to power assist the bed mover, so that lesser people can actually navigate and push the bed as well. Things like that. Firefighting robot we have thought about, and also for Airbus, we did something like the aircraft that is able to launch mid-air and to test out their flights. Okay, this is a big picture on drones and tethered drones and also UGVs that we have demonstrated in one of our National Day and National Stadium, right? So it's kind of a big thing to us, because unlike regular projects, right, National Day don't move. So no matter what, we need to get it work. And then the communication frequencies are very challenging as well. Everybody is using some sort of frequencies, and we are down to very challenging and narrow bandwidth, so we have to make do with that. So we have to get creative and use our fundamental engineering to do that. But that's not the point. The point here is, if you look at the extreme right-hand side, you can see a drone, the DJI drone. How cheap is that, right? So it mainly points to a sunset industry for drones for us. We are very sad to embrace that, but that's the sad truth. And that's the real truth, and we have to tail down on our drone activities, because things are getting cheaper and cheaper, and that's a good thing for technology, but for us, we have to pivot, because we can't be building custom drone platforms that is better than DJI unless it's very, very big drones. So we decide to move on. But we still do a lot of custom robots, things that is not typical in everyday sense. For example, on the left-hand side, just for appreciation, this is to check radiation on top of a container. So there's some outrigger that's automatically being powered as it moves further up. And also things like casualty relay robot that's used homeland security, following the line following techniques, and instead of autonomous. Of course, as we move along, it gets more and more autonomous, but back then it's actually line following robot. It has its merits, because in the red zone, we're able to lay the lines very quickly with our human perception, avoid obstacles, and then this structure just moves along. So it does have its own merits, because autonomous, if something comes up, it will just hang somewhere, right? But for this, it's a bit more stable. So we have to make sure that we have the right technology for the right applications as well. So even if the technology is moving as fast as what we can right now, but is the industry ready? We have to pause and think. Are they willing to even spend that kind of money, right, for that purpose? What problems does it solve? That's very important. So there's actually two fronts. So I would say the industry is actually one or two notch back. Sorry, the industry is one or two notch back. And we also do exoskeletons, very interesting stuff, passive or even active. We have explored electronics, hydraulics, pneumatic versions of it. Of course, we find that pneumatic versions actually work better, at least for the firefighters. And this is one of our Hope staff. Came a long way, and he's kind of a father of exoskeleton in our team. And together with a small team, we are able to churn out exoskeletons. This is very experimental. I would say that because back then, right, Marvel and Iron Man is the key thing, right? So everybody that wears metal, right, they feel invincible. But when the engineers actually wear that, right, they find that there's actually more things to work on, right? So it's still very experimental. So I believe one day we are able to be powered by these suits and give us more dexterity and also power to perform our tasks. But right now, I would say that it's very conservative. That's why you don't really see many effective power exoskeletons around the world. But how many years have it been for this kind of robotics? Okay, AMRs needs to evolve as well, but evolve in a way that it gets smarter, and when it sees obstacles, it's not just able to stop, but able to avoid it using visual and also other sensors. And we spin off a separate company called Sesto Robotics in 2018 so that it can focus on the product and the platform. And you can see on the right-hand side, it actually has removable payload later on, because initial part, we are integrating everything by itself. So our thought and process, everything is not really modular. As we go on, we want to scale a bit more. That's why we adopt modular solutions. So having a removable payload is very important for us, as it gives better ROI to the customers. Okay, so back to the tunnel inspection robot. So we make use of certain technologies that is somewhere in the middle of the Gardner curve. All right, so it's not to the extreme right, but it's not too far to the left as well. Because back then we find that if we get too conservative, right, it don't really serve the purpose of a tunnel inspection robot. So we have to do something there. But you know that there is a 80-20 rule. So the 20% that is lacking in the features, we have to make do and work out with the customer so that we can walk the journey together. If not, we will forever unable to embrace certain technologies. So that's very important. I will split the customers into actually two parts. One part of the customers, right, will be very profit and cost conscious, right? What can you save them? You can have the sexiest technology, but if it's not going to save them money or it's not going to solve their problem, they won't invest, right? They would like to see other people adopting it, but does not work out for the business. So after we told them the cost, they will start to ask you for a more cost affordable solution, and that's where the technology actually scales down. The other customer will be more tech focused, more for a show rather than to solve real world problems. We have that kind of customers as well, but yeah, so there are two sorts of customers, two categories. Then as we move along, we need to talk about scalability, because just making and doing platforms and solutions across many industries does not really work out like that. And we need to see how can we push the boundaries in terms of tech as well, and also to solve real world problems, right? So for example, on the extreme right hand side, you can see this autonomous forklift, outdoor forklift that's done actually a few years ago to test out whether it makes sense and what are the boundary conditions that we are going to have when we deploy autonomous forklift in outdoors condition. And the pallet is having payloads, right, that is double layer and is very flimsy. So these are real problems, not just able to detect the pallet and picking the things up and going to somewhere. What if the thing is flimsy? So what kind of mechanism should you have to balance the thing as well? And how can you structure the whole environment so that it can better be used in the real world? And then as we move along, we have a partnership with SIAC. We did engine inspection robots and also seat track inspection robots to check the conditions of the seat track, so that the inspectors is able to pick this up more effectively and leading to manpower savings. So if you take a look at this, the technology that we use is not the latest and latest. It's not the AI version of the technology, but it's like one step back because it just works for them and there's no reason to spend additional money. Of course, as the AI gets better, we will be a fast follower and adopter of it as well, so that we can actually put a bit of smartness inside and then make things work better. But that does not mean that they are willing to pay for that right now, because to use AI and stuff, the company, at least for SME, needs to deploy or have enough talents, right talents to actually do this as well. And how many months do we have before we can actually have that kind of capability and also to implement in the short duration of time that they want? So these are things that we also consider. Vertical farming as well. We are talking about robotics vertical farming. So vertical farming is pretty common, but I'm talking about robotics vertical farming is not that common. That's why we start to sensorize a lot of things, doing a lot of IoT and putting things in the cloud so that we are able to manage this automation. A lot of PLC has been used as well. But some of the projects like defense projects and some of the other customers, we are using a lot of on-prem stuff. So cloud access is not there. So we have to select our technologies accordingly. And yes, I think many of you guys have seen this before. That's the robotics middleware framework, as taught by many people as well. So we are into this like a few years ago under a grant by MOH and also NRP. Very fortunate to have the grant, thanks to them. And working together with our partners, we are able to come up with this middleware layer that was meant for the healthcare, but we all know that it's agnostic to the industries. That's why we use it in our projects as well. So not necessarily as a product. Sometimes we use it as a product, sometimes we put a layer into our project so that we can actually enjoy that kind of scalability and future proof. So it allows all the different brands of robots and systems to gel together, and also the infra to connect to this layer so that we have better command and control and also prioritization and also traffic control as well. So I think that is kind of the in thing right now, because a single solution does not come from a single brand of robots. So it comes from different sectors, come from different suppliers, different brands of robot systems. So as system integrators, we need to have something that is able to bring everybody together. So what is next for us? Right. So very, very recently, we have integrated more advanced payloads into different platforms. I think the dog platforms called the QUGV by us is very interesting, at least in the defense sector and also in homeland security, because of its ability to navigate through rough terrains, I would say. But we all know that the payload endurance is not really fantastic. Of course, it's getting better throughout the years. But once it gets better, we also have to think about where the dog belongs to. If it belongs to some countries that we can't really use, it just means that we don't have a good platform, all right? So we are also limited by all these kind of things. And also, if we use platforms from all around the world, if we need some secure communications, how are you going to do it? So we are also developing a certain secure comms kit, right, so that we can plug and play into different robots as we deem fit. So it all boils down to the application that is required, and then we develop a technology for it. And we don't reinvent the wheel. If there's something out there, we will definitely use it. And also the food cooking systems in the Chef Roboto. We started off with a fryer machine, and then after that, of course, we are looking into more fancy machines that uses visual analytics, also cloud-based, so that we can make sense out of the conditions of the food that is being cooked. And then we have this bipedal that is the latest platform that everybody is developing. Many people are good in certain things. Some are good at the dexterity of the fingers. Some are better at the gait, right, and also the spinal portion of it and how it behaves. But right now, everybody is at the teleops stage. Nothing autonomous yet that I know of, and it cannot work for long and very limited payload. But the point will come that it gets better and it gets smarter. So the smartness can come from AI and more conversational. It could be plugging in different things like the Lava, the Claude, the Llama into it to make it better usable by the industry. But one thing to caution also is that even if it has these conversational capabilities, right? Do the customers really need it, and how much would they pay for it, right? So that is something that we need to be practical about. So if they are not going to pay a lot, so then how can we even squeeze in and these kind of technologies inside right now? So I would say that there's some lag there, and the expectations is if everybody is doing it, it should be cheap. All right, so for AI is really on the left-hand side of the Gartner curve. So we are still monitoring this situation. We will definitely be a very fast follower on that because eventually it becomes a bit more mainstream and everybody is ready to adopt it. So in a nutshell, so how did we progress? We progress from small and fun robots, right? Things that fly in the air. And after that, we get a bit more practical because we need to survive. And they work on bigger platforms, but at that time, not really scalable. And then after that, we moved on to products and systems that actually work and scale in terms of solutioning as well. And then after that, we began to use more of cloud-based technologies, IoT, a lot of sensorizing so that we can gather a bit more data, right? So we use low-level AI because we roughly will know, because we are experienced in certain movements, parts, and the behavioral systems, and also in vehicles. So we are able to know how to categorize certain parameters and use low-level AI to determine certain characteristics, and also, for example, in preventive maintenance. Then there's an AI explosion lately, and it gets a bit much more smarter. So we see that robots will get even smarter, and hopefully the industry can actually catch up and pay good money so that all the different companies, right, can adopt it and present to the entire world and use it better, I would say. Right? So that comes to the end of my speech. I would like to end off with something that I always talk about. We need to fall in love with the problem that customer is facing and not really on the technology, right? So we need to find the right technology to our problem. So that is really the common mistakes that we also make back then. Some engineers will be very interested in certain technologies and will find always all the unique selling points to justify the use of our technology, but the numbers don't lie. When we do the numbers, it's not ready yet, so we have to discard. So that is something that is sad to say is still happening, and but nevertheless, I think both fronts needs to be pushed, technology and also industry, so that we can have a balance there. And it's up to us as system integrators also to find innovative ways, right, to catch up with the technology and also bring it to the industry, right, in a very cost affordable way. With that, I'll end my speech. Thanks.
Thank you, Daniel, for the sharing. Now, let's open the floor for questions. Does anyone have any questions? Oh, got one there.
Right.
Thank you for the great presentation.
Hi.
I'm Jim from ARTC, work on robotic systems. So, so very often we work with customers who poses the same kind of problems that you presented. We can talk about great technology, but is the technology affordable? So affordable automation is one of the key areas we are trying to work on now. So yeah, many startups also fail for the same reasons that you mentioned. So we can build great technology, but ultimately is there a demand as well as the ROI is justified? So what specific areas or how can ROS community and maybe other technologies specifically contribute towards building affordable automation? And I'm coming also from the aspect of industry where we don't necessarily deal with high value products. So let's say FMCG, small value products. So where if you talk about delivery robots, they say, okay, we can have part-time laborers. If you talk about other picking, packing tasks, we can have cheap labor, human labor. So why automation?
Okay, so to answer this question, right, how can we make it affordable? We have to look at the horizontals of it, of the technology. So if the technology can be applicable for a few industries, the ROI is actually spread. Then it actually makes sense for the company, right, to think hard and see whether we want to invest in that technology, because the technology can be used in many sectors, I would say. So in that sense, it will make better ROI for all the industries. So in that way, we are able to adopt it, right? But if you look at a single industry and we just go one-to-one, most of the times the newer technology, we can't really go too deep into it, because like what I mentioned, the talents, right? We need to secure the right talents as well, right? And also whether we are able to build our capability so fast that we can catch up and in time for the opportunity, because opportunity don't wait for you as well. So these are some of the factors that we need to consider, before we can actually make it a bit more affordable. Thanks.
Specifically on the role for ROS and other open technologies, do you have any specific comments on that?
We are not tied to actually one particular technology. We do use ROS in our mobile robots, as well as our beacon, which we call in the RMF. But in certain areas, we are actually not using ROS as well. So so we are system integrators. We have to see what is actually makes more sense for the application, and whether it has is a huge horizontal before we decide on anything.